Hi everyone, so welcome to the first video of Oceanography. This is on the YouTube channel. First and foremost, remember to hit that subscribe button and like the videos. I think that's what people say. I don't know, if I get 1,000 subscribers, I think I get one of those gold like YouTube buttons. So yeah, it's a goal of mine. Hey, whatever. But anyway, these are to help you with the notes, because obviously you are not here right now. Let's start going through them. So far, I've asked you to cover slides 1 through 7. We're going to do a quick review of that, and then we'll continue on with a little bit more in an upcoming video. So we're starting with the motion of the ocean slide. So it's title of the PowerPoint. That's where we're going. And first thing we're going to do is jump right into air currents. So air currents depend upon the tilt of the Earth, and we all know the Earth tilts off center at an angle of 23.5 degrees. Okay, so as it moves around, it continues on that 23.5 degree tilt, and that's why our equator, which is tilted at an angle, it's tilted at this angle right here, is not the hottest place on Earth. In fact, the hottest places on Earth are the Tropic of Capricorn and the Tropic of Cancer, and those are located below and above the equator. The equator is the most consistent temperature range on Earth. Okay. And all this has to do with ocean currents and how the ocean moves and waves that are generated, because they are generated by air currents. They are generated by the tilt of the Earth and the orientation towards the moon. It gives us our tides. So in the northern hemisphere, that's where we are. It is summer when the North Pole points towards the sun, and winter when it points away. And in the southern hemisphere, it is completely reversed. But we notice that because of the tilt of the Earth, when we think about where we are, right? We are directed towards the sun during summer. So this is our summer. Completely opposite of that is our winter. Then if we follow through, summer falls into winter and winter springs into summer. So if you can identify where summer is, then you can identify where everything else is. You will see this diagram again. I can promise you that. All right, but it's most important. Always look to the northern hemisphere. Always look to where we are. You can see right here in this area, we are pointed closest towards the sun. Moving on, we see that because the Earth is tilted at an angle, it has uneven heating. I want you guys to think about if we have, I'm looking on my desk for something that is ball-shaped. I don't think I have it. Anyway, if we have a circle and it's tilted at an angle, the sun's rays will deflect at the top, hit more straight on in the middle-ish area, and deflect at the bottom. That's what gives us uneven heating. These deflections at the top and the bottom. They are cooler areas. They're not getting the brunt of the sun's rays. Think about if you were playing football and someone's running at you at full speed. If you just take them on full speed, you're going to get all of their force. That's what's happening in the middle here. But if you kind of slide to the right or slide to the left, you're going to deflect them. Or if you kind of push them away, you're deflecting them. You're not getting the full force. Same thing here. The sun's rays are coming down and bouncing off. All right. So that's what gives the Earth uneven heating. Moving on, this is what leads to global currents. Okay. Global air currents flow north to south and back to north again in that direction on Earth. We could see that they create what's called convection currents. They heat up at the equator. As they rise, they start to fall back down towards the pole. This is a convection current, that circular motion. Same thing that happens in your oven, same thing that happens when you're heating a room. Convection currents. Okay? Warm air rises at the equator and cold air sinks at the poles. And our final slide to catch us up is the Coriolis Effect. I had you watch those 2 videos. It's actually pretty neat. It does show that water does spin in opposite directions in the northern and southern hemisphere. So if you did not watch those videos, I strongly suggest it. It's on the teacher staff page of the PHS website, along with all of your assignments. Please, guys, get those notes written, get those tests done. Okay, it's important that I receive that work back from you. Okay, that way I can see how you're doing and how you're making progress. Also, if you have any questions, please email myself or Miss Cody. I put her email at the top of the teacher page. Again, I will join you back with another quick video to explain a couple more slides, but always remember, like and subscribe. I'll see you guys. Bye-bye.